is Dr. Dipesh Patel and I'll be teaching you Advanced Internal Combustion Engine. In today's video session, we are going to see the emissions from IC engine and its control. So, like we have seen a lot of different emissions that is being like injected into the atmosphere all the time, and here, particular for this video session, we are going to see what are the different types of the emissions which are created by the IC engine. So let's start with the introductions. Here we have seen so many times that in recent trend the world is facing a major issue of global warming. That is because of various pollutants that is being injected into the atmosphere from different sources. And IC engine is also a major source of pollution. And all the hazardous gases which has been emitted from the engine is causing the detrimental effect to not only human beings but into the surrounding ecosystem as well. And therefore, a lot of different strict rules and regulations and a lot of new research and innovation is being created, is being taken out by the different peoples to reduce the effect of the emissions, to reduce the overall emissions from the IC engine without sacrificing the power on the fuel consumptions. So here we are going to see a lot of different pollutants. So here this is the different types of the pollutants such as the carbon monoxide, CO, hydrocarbon or unburned or partially burned hydrocarbon, FC, oxide of nitrogen, NOx, then oxides of sulfur, particulates and soot. The top four are mostly emitted in spark ignition engine, while they are both being emitted by the SI and CI engines, spark ignition engines and the compression ignition engine, while the remaining two, the particulates and soot and smokes, are mostly created or generated in CI engine. Now, the quantity of these would be differ for different types of the gasoline blends. For example, the carbon monoxide is approximately 200 gram per kilogram of fuel, hydrocarbon is approximately 25 gram per kilogram of fuel, and the oxide of nitrogen is approximately 20 gram per kilogram of fuel. And all the remaining ones are lower as compared to the others. So here we are going to see these pollutants one by one. But before we go through each of them, in this graph, you see the effect of the equivalence ratio or air fuel ratio on emissions. And here we are going to talking about all the three major pollutants of the IC engine, such as hydrocarbon, HC, then nitrogen oxide, NOx, and CO, carbon monoxide. So you will see that on x-axis, fuel and air equivalence ratio. On the y-axis, the amount of emission in exhaust flow. It has been observed that if the mixture is rich, means the quantity of the fuel as compared to the air is higher, then both HC and CO emission is higher. So HC and CO emission is increasing as the fuel is become richer. That is because that the enriched fuel does not have enough amount of oxygens to create the carbon dioxide CO2 and with the generations of HC and CO. On the other hand, if you look at the NOx emission, the NOx emission is found highest at stoichiometric conditions when air fuel ratio is chemically correct. It is because the NOx emission is directly connected with the temperature, and the highest temperature achieved inside the combustion chamber during the perfect mixture, during the stoichiometric mixture. So the NOx emission is lower in both rich and lean mixture, while it is highest in stoichiometric mixture. So here you can see the graph that represents the overall emission of the NOx. Next, we are going to see the different types of the emissions, and first one is hydrocarbon. Now, hydrocarbons is having the quantity of approximately 6,000 part per million of hydrocarbon component, and that is mostly equivalent to 1 to 1.5 percentage of the fuel. Hydrocarbon mostly generated because of the like the overall air, the low quantity of air, and since it does not have enough amount of the oxygens to convert all the CO in CO2, and therefore the CO emissions end up in the combustion chamber. Here, few are the causes of hydrocarbon, and the first cause is incomplete combustion. This is a major cause of the creations of the hydrocarbons inside the combustion chamber, and you can see there are a couple of more things that would be describe the types or conditions of the incomplete combustion. Even during the perfect combustion, that is mostly not achieved in combustion chamber. However, if the combustion is nearly perfect, though certain amount of hydrocarbon is always produced. So the causes of incomplete combustion are, the first one is improper mixing, and the second one is flame quenching. When there is a not proper mixing of the air and fuels, you see that all the fluid particles would not have enough amount of oxygen. And these fluid particles leave the combustion chamber without reacting, and therefore they would end up into the hydrocarbon. Second one is flame quenching. When flame is, we know that the flame is traveling from the one end to another end, from the spark plug to the another end. Now, when it reaches to the wall, or when it is reached away from the spark plug, due to the surrounding temperature, it gets quenched. And since it gets quenched, some certain amount of the fuel would remain unreacted. Also, during the expansion stroke, both pressure and temperature would reduce, and therefore certain amount of the fluid particles would remain unreacted because of the flame quenching aspects. So, two of the reasons for incomplete combustion are improper mixing and flame quenching. Second reasons for the hydrocarbon is crevice volume and flow in crevices. So crevice volume is the volume in between the piston ring and the crevice gap, or piston gap is being provided to fit the piston ring. Now, when the compressions take place, because of the high pressure, certain amount of the fluid would escape from the combustion chamber and enter into this crevice. That would almost take 3.5% of the fluid that is being remain into the combustion chamber. Now, during the expansion stroke, obviously the pressure inside the combustion chamber is reduced, and at that time the pressure inside the crevice volume is higher as compared to the surrounding pressure, and therefore the fuel that would remain in crevice volume would run out from the volume and flow into the combustion chamber, back to the combustion chamber during the expansion. So, crevice volume would also create some unreacted fuels into it. Furthermore, this issue, like the unburned fuel in crevice volume, is highest during the cold combustion, because like the ring would expand after it reaches to a certain temperature. And one more reason for that is, as the vehicle gets old, engine is old, certain amount of these rings would get size would reduce because of the erosion, and therefore the crevice volume will reduce, and much more amount of fluid will enter into the crevice. So we need to look into these position networks to reduce the hydrocarbon. Third thing is the leakage past the exhaust. Now, as I said, a certain amount of the fuel that is entered into the crevice volume, or that would remain in the combustion chamber without reactions, these unburned fuel particles would get out from the combustion chamber through the exhaust valve and entered into the atmosphere. That is the reasons for the hydrocarbon. Then fourth one is the valve overlap. You know that there are like both valves would remain open for a certain period of time. So during that time, certain proportions of or portions of the fuel would certainly escape from the combustion chamber as enter into the inlet valve. So few fluid particles escape from the exhaust valve during the valve overlapping and they would remain unburned. Then deposit on the valve. The fuel particles especially during the compression stroke, they would deposit into the combustion chamber wall since the pressure inside the combustion chamber is higher, and these fluid particles get deabsorbed during the expansion stroke since the pressure is reduced during the expansion stroke, and they would escape from the outlet valve. And the last reason is oil in combustion chamber wall. We know that there are a small thin oil layer created into the combustion chamber wall, between the combustion chamber wall and the piston to provide the proper lubrication. So, like certain amounts of the fluid particles would also be absorbed by the oil film during the compression stroke. They get absorbed automatically since the pressure reduces, combustion chamber reduces the expansion stroke, but they would remain also unburned, and they would also be a part of the emissions of the hydrocarbon. So these are the causes of hydrocarbon in ICM. If you want to reduce the contents of the hydrocarbon, we have to look into all these methods and we have to work on it to reduce the amount of emissions that is contributed to the ICM. Second one is carbon monoxide. Now carbon monoxide is a poisonous gas. It is a colorless and odorless, but it is highly poisonous gas, and it is mostly created during the rich mixture, during the combustions of the rich mixture. Means the engine when operated in initial conditions, or when engine is operated with the highest amount of the load, or when you suddenly open the throttle. At that situation, the rich mixture enters into the combustion chamber, and the highest amount of the carbon monoxide. Now, carbon monoxide is created because it does not have enough amount of oxygen to convert all the carbon into them, and therefore they would turn into the carbon monoxide. Now, carbon monoxide is considered as an undesirable emission because it does not create any pollutions. It is not only creating the pollution, but it is also considered as a loss of chemical energy because we are losing the heat energy in the form of the carbon monoxide. So therefore, carbon monoxide, the emissions of the carbon monoxide should be as low as possible. And it is highest, emissions of the carbon monoxide is highest during the startup. As I said earlier, since during the warm-up, the engine requires a rich mixture, and whenever there is a rich mixture, it will have a higher carbon monoxide. So, carbon monoxide will be highest, especially during when the vehicle starts, especially during when the vehicle is moving into the field, or when it is having high speed. You will see the formula here: CO plus OH equal to CO2 plus H. If the carbon monoxide is having enough amount of the oxygen, then in that case we will convert that into the carbon dioxide and the heat. But if we have the highest amount of the carbon dioxide, means if there is a smaller amount of the availability of the oxygen, then in that case we are not only creating the carbon monoxide emission, undesirable emission, but also loss of. Then next one is the nitrogen oxide. Now nitrogen oxide is up to 2000 ppm of the of overall exhaust gases. It is approximately 2000 ppm parts per million of the exhaust gases, and it also undesirable because it is major cause of photochemical smoke. You might have recently studied that the smoke is created especially in the lab, and that is due to the emissions. That is due to the emissions, especially nitrogen oxide. Nitrogen oxide always reacts with the atmosphere to form a ground layer also. Ground layer ozone is always there because it is creating the photochemical smoke, and as a major issue to human health and overall ecological. Now, like the past two, CO and HC, they both are highest during the rich mixture, but the level of the carbon, level of the nitrogen oxide is observed to be highest when there is a stoichiometric ratio. When there is an actual ratio between 14.1 to 16.1. Because at that time the flame temperature is highest and carbon monoxide is always created, always highest when there is the highest temperature, right? And also the concentration of carbon nitrogen oxide is not only dependent in the temperature, but it also depends on the actual ratio, part in advance, engine design, and mode of vehicle propulsion. And also pressure play an important role as well, because pressure is directly proportional to temperature. And the last thing is particulates. Now particulates is found highest in CIL, in ether engine. So basically particulates are the visible flow that you can see in exhaust gas. You see the dusty gases coming out from the exhaust valve, from the silencer or through the muffler, that is known as the particulates. Now particulates are mostly consist of the soot and smoke. Soot is the bunch of the carbon particles, small carbon particles which are having the size of approximately 15 to 13 micrometers, and like the bunch of these carbon particles creating the soot particles. So particulates mostly consist of the such kind of the material. Now, the diesel particulates mostly consist of the solid carbon, which is also known as the soot, at exhaust temperature below 500 degrees Celsius. And a soot is also created during the particulates are also created in higher level, especially during the rich mixture, because there is not enough amount of oxygen to convert them into the fuel. Now it is basically created in a fuel-rich zone within the cylinder, especially during the combustion, and you observe the highest amount of the particulate matter during the initial condition, during the startup condition, during the vehicle is running under load, or during the uh, vehicle going into the upstream. So this is the last emissions of the SIM. So we have seen the different types of the emissions which has been created in the engine, and we are going to see what is the remedy, what are the different types of the remedies, what are the different modifications that can be achieved to reduce the emission as well as possible. Thank you very much.